Okay, so in part B of P5, we talked about multiplying and dividing rational expressions, right? We started with simplifying, then we multiply and divide, which means we're going to, if we're multiplying, factor all the parts of our fraction that we can, cancel top to bottom or diagonally. And then if we're dividing, we're doing stay, change, flip, keep, change, flip, and doing the same. Keeping the first, changing the sign to multiplication, flipping the second, and then factoring, cross-canceling or canceling top to bottom. So with number 1, this is multiplication, so I just need to look up all the spots. So x minus 8 cannot be factored. On the bottom, I'm looking for the factors of a positive 48 that sum to negative 12, which would be what? Are there factors of 48 that sum to negative 12? If you go through them all, I think I heard a no, but if I go through them all, right, 1 and 48, first of all, both of them have to be negative, right? Negative 2, negative 24, negative 3, negative 16, negative 4, negative 12. 5 does not go into it. Negative 6, negative 8. 7 does not go into it, and 8 is back to the beginning. So this is actually as is prime. I look at the top right, and I've got x and x, factors of negative 80 that sum to positive 2, which are what?
Negative 8 and 10.
Good. Negative 8, positive 10. And then the denominator, x squared minus 100, this is different to 2 squares, x plus 10, x minus 10. Now I cancel out as much as I can, right? So x plus 10 and x plus 10 cancel from here, but that's it. I can't cancel anything else out. So sometimes it's going to look long, okay? In the numerator, I can do x minus 8 times x minus 8 over x squared minus 12x plus 48 times x minus 10. Or I could rewrite that as x minus 8 squared over x squared minus 12x plus 48 times x minus 10. Okay, now let's say, for example, that this was a 14 instead of a 12. So as it was unfactorable, but if it was a 14 there, I would have gotten x, let me do this in different colors so we know it's different, x minus 6 and x minus 8. Then the x minus 8s would have canceled. I still would have had one x minus 8 in the top, x minus 8. And the bottom, I would have had x minus 6 and x minus 10. So if that was factorable on the bottom left, I would have factored it and reduced it. It's not always going to be factorable. You're not always going to cancel everything out, but obviously you should at least cancel something out usually. Questions on that one? Okay, so then number 2, this is division. So keep, change, flip. I flip it before I factor it, but you don't have to. So I'm going to do x plus 3 over x plus 2 times x squared plus 5x plus 6 over x to the third plus 27. Left side is already reduced. It can't be factored. Right side, factors of positive 6 that sum to positive 5, x plus 3 and x plus 2. Denominators, perfect cubes. So this would be x plus 3, and then, so the cube root and the cube root, x squared, 3x, and 9. Signs are same. Sorry, same for the first one. Opposite for the second one. Positive for the last one. Now we do the canceling. So top to bottom or diagonally, I can cancel the x plus 3, but I can only cancel one of those. I can't cancel that and this. Left to right, diagonally, I can do the x plus 2s. So what's left in my numerator is x plus 3. What's left in the denominator is x squared minus 3x plus 9. Questions on that one? All right, now 3 again, division. So we're going to do the keep, change, flip here. keep the first one, change the sign to multiplication, flip the second one. Now factor it. This becomes x plus 4 and x minus 4. Top right, x plus 10, x minus 9. Bottom right, x plus 10, x plus 4. So I can cancel the x plus 4 in the top left, the bottom right. I can cancel the x plus 10 in the top and the bottom on the right. And then I've got x minus 9 and 9 minus x. Those are not the same, but they are opposites. So I canceled through one and the other, and I put a negative 1 on the front. So my answer's got a negative out front. The x minus 4 is the only thing left in the top, and there's nothing left in the bottom. So this would be negative x minus 4 or negative x plus 4.
Can you go back up to 1?
Sure. Remember, I changed it, so the first one is there. And then I said what would have happened if it was a 14, and that's what's in the pink.
Oh, okay, that's why I got
Yeah. Other questions from the warm-up? So your quiz, which is Wednesday, is going to cover everything up until today. Part of it's multiple choice, part of it's open-ended. We didn't make any of the upload pictures this time, so you can kind of prepare yourself for what's to come. It's going to cover everything that we're going to cover up till today. So it's the factoring completely that we did last week, the simplifying, the multiplying, and then what we're going to do today, which is adding and subtracting. And again, that's Wednesday. All right, so I cut it off. What number? I don't even know. 3? Is this what this was? On the homework, perform the division and simplify. So I'm going to keep, change, and flip. Then from the top left, x plus 2, x minus 2. Top right, take out a 2. And now I can cancel the x, well, the 2 goes into the 12 6 times. X minus 2 and 2 minus x are opposites, so that gets a negative. And then my numerator has 2x squared, x plus 2's, so I can do the negative out front. X plus 2 times x plus 2 over the denominator just has the 6, which can be negative x plus 2 squared over 6. Webassign took the 1/6 out. You don't need to do that, okay? You could keep it in the denominator. It's just that the negative's got to be there. All right, this was number 5, perform the multiplication. So this time it's already multiplication. I don't need to keep, change, flip it, but I do have to factor it. So if I factor the top left, okay, put this in parentheses, there's a variable on the front and at the end, which means there's going to be a variable at the front and at the end of each of our parentheses. Then I'm looking for the factors of negative 6 that sum to positive 5. So this would be a positive 6 and a negative 1. The bottom left, I can take out an x squared and I get x plus y. Top right is already factored. Bottom right, parentheses again, an x at the front, a y at the end. And then I'm looking for the factors of positive 6 that sum to 7, which is positive 6 and positive 1. Now comes the canceling. So I can cancel an x plus 6y and an x plus 6y. And I can cancel one of these x's. In the numerator, I now have x minus y over the denominator. I have x and x plus y. And then another x plus y. So I have x minus y over x times x plus y squared. Good? Yeah, okay. Remember that you can always go back and practice extra examples of these, okay? You just click practice another example. And remember that you still have your ebook. So don't forget that the ebook is, as soon as you get into WebAssign, ebook is on the bottom right corner so that it has extra questions in there as well. Plus, obviously, that like if my notes don't explain things well enough, or you need some extra explanations, all the sections are there too, so you can look at that. All right. We're almost done with P5. There is one more section on P5, but we're going to save that till after the quiz. We are going to do adding and subtracting rational expressions today. So continuing to practice factoring because you need it in order to add and subtract. But now we're dealing with least common denominators. So it's a little bit harder. It's like an extra step on the adding, the multiplying and dividing, okay? But it's pretty simple. So when you're adding and subtracting rational expressions, they have to have the same denominator, just like every fraction. We're going to factor the denominators first before we find that least common denominator. Then we're going to find the least common denominator. So we take each term or expression to the highest degree that's there. Then we multiply each term by what's missing from the denominators. And then add and subtract the numerators. And the answers should have that least common denominator as the denominator. So we're going to work through some examples, but here's your steps should you get stuck somewhere. All right, so we're going to baby step our way into these. Okay, they say simplify. So we're adding fractions that obviously don't have the same denominator here. I have to find the least common denominator. So what's the least common multiple of 2 and 3? 6, right? So this has to become something over 6, and this has to become something over 6. I multiply by 3 here, so I have to do the same here. This is 3. I multiply by 2 here. I have to do the same here, so it's 2. And then I get 3/6 plus 2/6, which is 5/6. Then I go to 2. My denominators are 6 and 12. What's the least common denominator there? 12. Good. So the one on the right I don't have to change, but the one on the left I have to multiply by 2, so I'd get 2/12 plus 1/12, which is 3/12, and that reduces to 1/4. So fractions always need to be reduced. Not everybody's favorite, but something you've been doing since elementary school, so we're good so far, right? All right, then we get to ones with expressions. So now we've got variables in the denominator, okay? When I look at these two denominators, they're the same. So I actually don't have to change anything in my denominator. I just want to add the numerators because that says 1 plus 2. So I'd get 1 plus 2 over x plus 1, which is 3 over x plus 1. Usually on multiple choice, you will see something like the domain restriction that says x can equal -1. Okay, that just means that, remember we talked about it at the beginning of Friday, or the beginning of Thursday actually, if there's a variable in the denominator, what's there can't equal 0 because it would make it undefined, and that's where this restriction comes from. So usually on like a multiple choice or standardized test, you'll see it written as this, and then it will say x cannot equal -1, something like that. Just know what that's what that means, okay? There's a restriction on it because there's a variable in the denominator. All right, now 4, again, denominator's the same, so I don't have to find a least common denominator, but this time there's a negative in between these two, which means it's x plus 1 minus, put that 2x minus 3 in parentheses to remind yourself to put the negative with both terms. So this negative now gets distributed, and I get x plus 1 minus 2x plus 3 all over x plus 2. And then I have to combine my like terms. So x minus 2x is negative x. 1 plus 3 is 4 over x plus 2. And the restriction on this one would have been that x cannot equal -2. Good so far. All right. Now we get ones that don't have the same denominator and they have variables in them, okay? So number 5 says 1 over x plus 5 over 6x. So I have to look at my denominators, which are x and 6x, and I have to find the least common denominator of them. So if I look at the numeric part first, it's 1 and 6. What would be the least common multiple there? 6. And then they both have an x at the first, so I have to have the x as part of my answer. So the one on the right is already fine. The one on the left I have to get equal to something over 6x, which means I'd multiply this by 6 and this by 6, and I get 6 over 6x. So I get 6 over 6x plus 5 over 6x, which becomes 11 over 6x. Questions on that one? Oh, and the restriction would be x cannot equal 0.
Are they going to want us to write it as an improper fraction?
Say that again.
Are they going to want us to write it as an improper fraction if it
Yes, good question, Madison. You keep them improper, okay? Unless it's reduced, you can't, like unless I was 12 over 6x, you leave it the way it is. All right, number 6. Now my denominators are x and x plus 1. Notice this is not multiplication anymore. So I can't make my least common denominator 1x, okay? This is its own expression and this is its own expression. So the least common denominator is the product of those two expressions, which would be x and x plus 1. Now I have to make 1 over x become something over x plus 1. X times x plus 1, sorry. And I have to make 1 over x plus 1 something over x times x plus 1. So this is what we mean by multiply the numerator by what's missing from the denominator. From here to here, I need the x plus 1. So I would have to multiply 1 times x plus 1. And I'd get x plus 1. From here to here, I'm missing the x. So I'd have to multiply by this by x, and I get x. So my new fractions are x plus 1 over x times x plus 1, plus, and that's what comes from here, x over x times x plus 1. Now the denominator is the same, so I can add straight across x plus 1 plus x all over x times x plus 1, which equals 2x plus 1 over x times x plus 1. You'll leave it just like that. Now there's two restrictions because x itself can't be 0 and x can't equal -1. Those would both make the denominator 0, which makes it undefined. So these questions and the quiz, I mean, I don't know, we didn't get to the test yet, but on the quiz, these questions are multiple choice. They'll already be part of your answer. Just know that's what they are. So it's not like I'm going to give you this with two different restrictions. That would be your answer, but you would also see the restriction attached to it. Questions on that one before we move on? Okay, now go to 7. Now I've got x plus 2 and x minus 4. Those are not the same things. They are their own expressions, which means my least common denominator is the product of the both of them. So I have to make 1 over x plus 2 have the denominator, that's x plus 2, x minus 4. And I have to make 3 over x minus 4 have the denominator, that's x plus 2 times x minus 4. So what's missing from here to there is the x minus 4. I multiply that times 1, and I get x minus 4. What's missing from here to there is the x plus 2. So I have to multiply the top by x plus 2. Distribute this time, and I get 3x plus 6. Now those take the place of the fractions that are already there. So I get x minus 4 over x plus 2 times x minus 4 minus, because that's the sign in the middle, 3x plus 6 over x plus 2, x minus 4. Now the denominators are the same, so I can combine my numerators. X minus 4 minus parentheses, because that minus is going to go to both, 3x plus 6 over x plus 2, x minus 4. The minus goes to both, so I get x minus 4 minus 3x minus 6 over x plus 2, x minus 4. Combine my like terms, x minus 3x is negative 2x, negative 4, negative 6 is negative 10, over x plus 2, x minus 4. And again, there would be two restrictions there. X cannot equal negative 2, and x cannot equal 4.
Point of multiplying the x minus 4 times the 3x plus 6 in parentheses.
Multiplying the x minus,
Multiplying it. Oh wait, is that oh never mind. You're multiplying in the negative 1. I thought you were multiplying x minus 4
oh, no.
times the.
Yeah, I just distribute the negative into it. All right, you try 8. See how far you can get on your own with number 8. All right, so who can give me the least common denominator for x minus 3 and 3x plus 4? Good. The product of the two. 3x minus 3 times 3x minus 4. So I have to change x over x minus 3 to have that denominator. And I have to change 2 over 3x plus 4 to have x minus 3 times 3x plus 4. So what's missing from my first one, from here to there, is the 3x plus 4. Now I have to distribute an x in here, and I get 3x squared plus 4x. Missing from here to there is the x minus 3, and I distribute the 2, and I get 2x minus 6. Everybody good so far? Yeah, okay. So now this is the first one, right? So it's 3x squared plus 4x over x minus 3 times 3x plus 4. Minus, because that's what's there, 2x minus 6 over x minus 3 times 3x plus 4. Denominators are now the same. So I would rewrite the numerator, 3x plus 2 plus 4x. Minus goes to both, so minus 2x plus 6 all over x minus 3 and 3x plus 4. Look to see if you can simplify, and this time I can simplify the numerator by combining 4x and negative 2x. So I get 3x squared plus 2x plus 6 over x minus 3 and 3x plus 4. The last thing you want to check for is to see if my numerator can be factored, okay? There are no, like if you think about doing first times last, 3 times 6, there's no factors of positive 18 that sum to 2. So I know that's prime, and I can leave it the way that it is. If I had like multiple choice, the restrictions that are going to be included is that x cannot equal 3. And x cannot equal negative 4/3. I would get that by setting them both equal to 0. But you don't need to worry about getting them yet. Just know that those exist. How'd we do? How many of you got it right? Good. Questions before we move on?
How, when you were multiplying towards the beginning, when you were multiplying the 2x, the 2 times the x minus 3.
Yeah.
Did I do that wrong? Because I didn't like get the 2x minus 6. I just got x minus 6.
You didn't do the 2 times the x. You got to do the 2 times the x and the 2 times the negative 3.
Oh, okay. I just did 2 times the negative.
Yeah, you got to distribute it to both, so be careful. Okay, last slide of examples on this one. Okay, and again, we'll go piece by piece. So look at number 9. My denominators are 2x minus 1 and x plus 2. Neither can be factored, and those are both different terms. So my least common denominator is the product of them, 2x minus 1 and x plus 2. I have to make x over 2x minus 1 be something over 2x minus 1 and x plus 2. And I have to make 1 over x plus 2 become something over 2x minus 1 and x plus 2. Missing from the first denominator to the second is x plus 2. So I'm going to distribute the x to both, and I get x squared plus 2x. Missing from x plus 2 to the LCD is 2x minus 1. There's a 1 there, so when I distribute the 1, I just get 2x minus 1. Now rewrite them, x squared plus 2x over 2x minus 1 times x plus 2. There's a minus in between, so I put a minus. 2x minus 1 over 2x minus 1 times x plus 2. Now the denominator's the same. So I rewrite the numerators, x squared plus 2x. The negative goes to both, negative 2x plus 1 over 2x minus 1 and x plus 2. Combine my like terms, 2x minus 2x cancels out, and I get x squared plus 1 over 2x minus 1 times x plus 2. Numerator cannot be factored, so I can't simplify. Restrictions would be that x cannot equal 1/2 and x cannot equal negative 2. Questions on that one? All right, number 10. So this time, hopefully you catch it because you've been factoring like maniacs for the last 2 weeks. But the bottom left denominator, x squared minus 9, can be factored. That factors into x plus 3, x minus 3. So now I ignore the original denominator and I look at these two, okay? Both have an x plus 3 and it's only raised to the first power. So that is part of my least common denominator. X plus 3 to the first. I don't have to do x plus 3 squared. You just take it to the highest power separate. And also I have x minus 3. So the product of those two is my least common denominator. So I have to change 2 over x plus 3 times x minus 3 into something over x plus 3, x minus 3. And I have to change 4 over x plus 3 into something over x plus 3, x minus 3. So what's missing from my first denominator to my least common denominator? Kind of a trick question because what's missing?
Nothing.
Nothing, which means I keep my numerator as a 2. I don't have to change it. But if I look at the second one, x plus 3 to x plus 3, x minus 3, that one's missing the x minus 3. So then I distribute the 4x minus 12. And then I rewrite my fraction sum, 2 over x plus 3, x minus 3. This time it's a plus. 4x minus 12 over x plus 3, x minus 3. Because it's a plus, I just combine my numerators. 2 plus 4x minus 12 over x plus 3, x minus 3. Combine my like terms here. 4x minus 10 over x plus 3, x minus 3. Now I can factor my numerator because I can take out a 2 and I'd get 2x minus 5, x plus 3, x minus 3. But nothing cancels. So both of these answers are acceptable. You do not need to factor out the 2. If it canceled something out, then you would need to factor out the 2. But it didn't cancel anything out, so I didn't need to.
I looked at this in the beginning. How was the 2 like okay? Like why didn't you do anything to it?
Hang on just a second. Taji, can you put on your camera? Did you have to come back in twice?
Sorry, no, my.
Oh, no, it's okay. I just wanted to make sure somebody wasn't trying to disguise themselves as you. Sorry, go ahead, Madison.
I was saying back in the beginning, how did you know that like you said you didn't have to do anything to the 2 over?
Because this is the same as this. So the goal there is to take the left side and multiply it by what's missing, right, to the right side, but there's nothing missing, which means I don't have to change the numerator.
Okay.
So,
Go ahead.
sorry. So on a test, can we factor out even if it doesn't cancel still?
So the quiz would be multiple choice for this question. Keep that in mind. It will either be one way or the other. Just know those are both right. It's not going to give you both and one's right and one's wrong. For the test, I don't know what format it will be, but when we get there, I'll remind you.
Okay.
Like, do you know also for like WebAssign which one it would take?
It'll take both for WebAssign.
Okay.
Yeah. Good question. All right, now look at 11. So denominator for the first one can't be factored. X plus 1 is as simple as it gets. Second one, x minus 1 is as simple as it gets. Now that third one can be factored to be x plus 1 and x minus 1. Now when I look for my least common denominator, I'm looking for the least or the highest exponent for each of these. So this is x plus 1 to the first. This is x plus 1 to the first. So it's got to have an x plus 1. This is x minus 1 to the first, and this is an x minus 1. So it's got to have an x minus 1. So now I have to change 3 fractions. 2 over x plus 1 has to get x plus 1, x minus 1. 2 over x minus 1 has to have x plus 1 over times x minus 1. And 1 over x plus 1, x minus 1 has to have x plus 1, x minus 1. So now I look from the left to the right here. X plus 1 to this is missing the x minus 1. And I distribute that in 2x minus 2. The second one, x minus 1 to the least common denominator, is missing the x plus 1. So I get 2x plus 2. And the last one, everything's already there. So I just carry over the 1. So now I get the first one, which took the place of this, which is 2x minus 2 over x plus 1, x minus 1. Plus the second one, 2x plus 2 over x plus 1, x minus 1. Plus 1 over x plus 1, x minus 1. Now if this was a plus and this was a minus, then I'd make sure I'd show those signs. So just be really careful with your signs. So now your denominators are all the same. X plus 1. Oh, this should be a minus. I don't know. I was saying one thing and writing another. X plus 1, x minus 1. And the numerators, I'm going to add straight across because it's all addition. 2x minus 2 plus 2x plus 2 plus 1. And then from there, you want to combine your like terms. So I've got a 2x and a 2x. That becomes 4x. I've got a negative 2 and a positive 2. That cancels out. Plus 1 is a plus 1 over x plus 1, x minus 1. Restrictions on this would be that x cannot equal -1 or +1. Questions on those? So the only other thing that I would point out is if your denominator, because you might not see it today, but you might see it in like a standardized test. Let's say it was this and this, okay? So they're both the same expression, but one is raised to the power of 1 and one is raised to the power of 2. So when you're finding a least common denominator like that, you have to take it to the not like that. You have to take it to the highest exponent, which would be the squared. If you had an x plus 1 and then an x plus 1 squared and an x plus 1 to the third, you'd have to take it to the third power, okay? So you always take it to the highest exponent. All right, questions on anything we talked about today? So your web assign is assigned, it's scheduled. You can go in there and you can get it if you want to start on that. The other thing I want to do is last week we didn't go all the way through the quiz question or the test questions, so I'm going to open that up and then go through the ones that we didn't get to, okay? So let me do that. If you don't have any questions on the test, then you are welcome to start your homework. Again, web assign and Canvas. Let me do this. We did that one. We did that one. Okay, I think we left off here. So this was the cube one, right? Which was 125 x to the 6th plus 27y to the 9th. Obviously, these are still important because you're still going to be factoring. So it's a perfect cube. When I cube root this, I get 5x squared. When I cube root this, I get 3y to the 3rd. So then my first set of parentheses is the combination of those two. Second set of parentheses is the square of the first one, 25x to the 4th. The product of the two, 15x squared y to the 3rd. And the square of the last one, 9y to the 6th. And then the signs go same. The first one was positive, so same, opposite, positive. And that should have been the answer for that question. Because that's the cube. The exponent here was 9. So the cube root of y to the 9th is y to the 3rd.
Because the square root of 9 is 3, right?
Correct.
It's different with exponent.
Yeah, divide what's on the outside in there.
Oh, okay.
Yep. Okay, then that one was good. That one was good. Here's another one. Okay, so the first thing you can do is move this entire parentheses down to the bottom because it is raised to a negative power. Now it's a positive 3, so that one moved. Then you can distribute. So I would have said x to the 21st, y to the 12th, over x to the 7th, y to the 14th, times distribute x to the 12th, y, I wrote over it, to the 21st. Then in the bottom, I can add my exponents. So I'd get x to the 21st, y to the 12th on the top, x to the 19th, and this one to this one, y to the 35th in the bottom. And then from the top to the bottom, we want to cancel by subtracting, but keeping it where it's the highest. 19 of these would cancel, and I'd get x to the squared in the top. 12 of these would cancel, and I'd get y to the 23rd in the bottom. All right, this one was good, good. This one, and most of it was because of the sign. So this was your fractional exponents. This said negative 32 to the negative 3/5. Negative in the exponent makes 1 over negative 32 to the 3/5. That's 1 over the 5th root of negative 32 to the 3rd power. The 5th root of negative 32 is negative 2, and negative 2 to the 3rd power is negative 8. So that should have been negative 1/8. All right, factoring completely again here. 3a plus AB plus 3C plus BC. I want to factor by grouping. First set of parentheses, I can take out an A. Second, I can take out a C. What's inside the parentheses is the same, and the A and the C get grouped together at the end. This is the same as the cube from before, just different numbers. So this is again a cube root. This was just the reverse order, but the numbers were the same. This one was good, 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 good. Just take out that one. I think we're good. If you have questions about specific ones, obviously, please feel free to ask. I'll work out this one. 2x to the 3rd, xy squared plus 2, xy squared negative x to the 3rd. So this becomes 8x to the 3rd, x squared, y squared plus 4x squared, y squared minus x to the 3rd. Or this should be in the front. And I get 8x to the 5th, y to the 2nd, minus 4x to the 5th, y to the 2nd, which is 4x to the 5th, y to the 2nd. That was good. I think the rest are good. Yep. All right, again, if you had specific questions you need me to go over, please let me know. Tomorrow we will do the warm-up for this section. We will review for your quiz, which again will be Wednesday, covering everything, factoring completely, adding, subtracting, multiplying, dividing, and simplifying those rational expressions. All right, homework is due tomorrow. Don't forget to work on it, and I will see everybody at the end of the day tomorrow. Have a fantastic rest of your day, guys.
Bye, thank you.
Bye.